user input and while loops. So why is this topic very important? This topic is very, very important because all we've been doing previously is we write programs where we get to change the values right by ourselves. We don't get to allow the end user to enter values. And programs, if you're going to be writing codes, actually you will not be writing codes that users will have to use your code, right? And let's say you have this program name and you have Aisha, and then maybe you have print print good morning. How is it spelled? Good morning. Then the name of the person, right? Good morning name, right? So you can see here we were the ones that fed the name. So what you're doing here, your code is only useful to a Python programmer that can come here and then say, okay, so I'm changing the name to Money, right? And then this will still greet the person good morning, Money, right? So we want to avoid that. We want to write the code where end users, that is people who are not necessarily programmers, and mind you, when you're giving out, when you're writing codes, you're not giving out your source code. What you're giving people is an interface where they can interact with your code, and that interface is called the user interface, right? Whether it is a command line or a graphical user interface, whether it is a command line interface or a graphical user interface. When we say command line interfaces, when you're using interfaces like this, like a PowerShell or a command prompt, right? When you have something like this, people can interact with your codes like this. And even these codes, all of these codes that we're writing are like command line codes, right? So we call it command line interface. We have the graphical user interface, which is like your application like this. Now you can click, right? Once you can click, you can drag, drop, all of those things. Once they are a graphical components, we call them graphical user interface, GUI. So just go read more on GUI versus, let me add this markdown. No, not close it. Please go back to your code cell. Let me change this. So go read on GUI versus CLI. It's not the it's not computer necessarily a computer buzzword, right? But you would have to understand some of these terminologies to be able to speak in tech grammar. But you can still fare well in the tech space without knowing some of these things. But I just feel why not you learn them, right? So the codes we've been writing so far are command line interfaces code, not graphical user interface. But then that will do. But we want to write codes where whichever interface the end user is able to interact with it, right? So that is where user input comes in. So we are not just writing codes that we already know the names of the people. We might not even know the names of the people. So we are going to write codes that people are going to enter their names, enter their details, and then the code will be able to execute, to be able to carry out an operation for them. And I know that's what all of us, most of us have been waiting. You've been like, I know you've asked yourself that question before. Okay, so what if I want my sister to now use this code? Does she have to come to Python and no, she doesn't. You can actually deploy these things as codes that people can use without necessarily even knowing the code or what the code entails, right? So that is where user input comes in, where the user enters his input by himself, whether it is that you're asking the user for his name, for a particular number, for for numbers to compute or whatever it is. We're going to see how to use user input to do that. So just to be sure we are following, let me just to be sure we are following, just give me a thumbs up if you're following and if you're ready for us to start collecting user input. Beautiful, beautiful. Okay, so we are not just going to collect user input, but we're also going to see another kind of loop called the while loop today. We're also going to see another kind of loop, and these loops are called while loops, and while loops are a cousin. I don't know if that English is correct, but they are cousins with for loops. So for for loops actually are called finite loops. When we start, I'm going to explain the differences between finite and infinite loops, but you already know the meanings of infinite and finite. So for loop is a finite sequence. You find out that the times that the for loop is going to run, we already know how many. We already know that even if we don't know the number of times it is going to run, we actually know that the for loop is going to run for a specific number of times before stopping, right? Whether it is for elements in a list, which of course you cannot have infinite number of elements in a list, right? No matter the size of the list, there is still an end to that list. So we can use a for loop. Whereas there are times where an infinite loop is needed. For example, if you're trying to grant a user access to a particular website and he needs to enter password, his password and username and maybe password, right? There are times where you can enter the password 1,000 times, as long as the as far as, sorry, the developers are concerned, you don't have a limit, right? There are, for other programming, sorry, for other developers, once you've tried up to 5 times, they block your account, right? But there are other developers where as much as you want, you can keep trying, right? It will not lock you out. So when you are not sure how many times something is supposed to be tried before, before the before the loop stops, once you're not sure, you can use an infinite loop, that is the while loop, right? And that's what we're going to be doing today. So we're going to be seeing, it's not like the for loop and the while loop are antagonist and protagonist. No, you're just going to look for a best use case. In fact, there are cases where both of them can be used, but then we're going to look for a best use case for all of these guys, for the while loop and for the for loop, right? So most Pythonians will always tell you that the default one is the for loop, the best one rather. The best one is the for loop. So it is when a for loop cannot be applied that you try a while loop, right? So if you're looping through a data set, it's likely that you're going to be using a for loop. If you're looping through list of items, it's likely that you're going to be using a for loop. But if you're going to be creating something like an authentication system, you might be using a while loop, right? If you want to catch errors, error catching, we're going to be doing error handling later. I think that will be topic. That will be after next week. Yeah, a week before our webinar, we're going to be doing error handling, how you can help users catch some of these errors. So in that error handling, we're going to be seeing how to use while loop to catch some errors. I have been using a lot of grammar. Let's get to work. I know some of you don't like grammar, so let's get to work already. So now I'm going to use this simple example to talk about user input, right? Now, if we don't want to write a code that we ourselves will have to enter the name, at the back end, because this is the back end. The back end is where you're writing the codes. The front end is the interface where the user is using it. This entire Jupyter notebook and this browser we're using is the front end we're interacting with, because we're not interacting with the codes, right? I know we're writing codes here. I'm just trying to explain that this browser. Oh, let me go back to another page so that I'll be fair to myself and to all of us. Okay, so this is LinkedIn. So when you are in LinkedIn, what you're doing is you're interacting with the front end, right? We call it the front end. So this is the user interface, right? Just like I spoke about GUI and CLI. Whereas if you're coding, if you are writing codes, right? These developers that develop LinkedIn, actually, there is what we call the back end, and the back end is where they route the codes of what we are seeing here. The result of what we're seeing here is actually results of multiple codes running sometimes simultaneously behind the scenes, right? So this one now that we are seeing and we are clicking here is the user interface. We have the back end, or what you can call the front end. We have the back end. So here now, we don't want the users to be interacting with the back end, right? So we will make the code in such a way that they can have their own front end and they can interact with it. So now I can do this. There's what we call the input command. Input, just like print. This one is also input. So input collects information from a user. That is what the input command does. And let's do this. So input, if you do this and you run this, input will just ask for an input. And if you don't enter this guy, it is not going anywhere. It will wait for you to enter an input before it moves to the next guy in line. So now input, let's assume his name. So if I enter money here, of course you can see it gave me the value of money, it printed money, right? Now you can see that, but how will the user know that this is what is required of them to enter, right? So I can actually come here and add a string, and then what will I put in the string? I can put enter name like this. Sorry. So if I run this, what I'm going to have is I'm going to have a code which is asking me to enter my name. Now you can see this is a bit descriptive, and that's how you get to fill in your, what do you call them, things like your Facebook accounts, and all of those things. So we're going to see something like that. We're going to collect more details and see how we're going to build on what we've learned previously. So enter name. So my name is Manny. So what happens? You can see it printed out the name, the value of the name Manny, right? So this is how you collect user input. Now, what if I want to store this in a variable? Now I can come and put name here is equal to input. Then I can tell the user now to enter his name. Let me enter Manny. Now it has collected the name. Now you can see that it did not print it because it stored the name in a variable called sorry, it stored yeah, sorry, it stored the name in a variable called name, right? So let's print name and see. You can see name is holding the value money. Now, if I want to work on this code, I can just come here, copy this, Oga, bring it here, rather here, and then once you enter your name, it greets you, right? So I can just add a comment here. Some of us are not very good at adding comments. I can just add a comment here, collecting user name, and then here, greeting user. So you can see how you can collect user input. So if you want to write something, if you want to write a game, and after this class, I even have an assignment for you, a personal assignment at that. I don't want us to have an extra week where we're going to talk about that. For the previous cohort, I spent a week to explain to them how to code that. But for you, I don't think we have that time. We're already running out of time. So I might just give you the video to go watch how you can be able to create a simple game from this. And the game we created last class, I think was it rock paper scissors? No, it was not rock paper scissors. It was number guessing game, right? And it was beautiful. And what do? You just enter numbers, you just enter your name, you just enter numbers and the rest. Like while the computer handles the coding and the rest. So that's what we that's to tell you that what you've learned so far, you can develop good and useful things, right? So we've seen how to collect user input, and we've even seen how to save it as a variable. We've also seen how to greet the user or to print a message to the user, right? So what how about questions? When we have questions like so if you don't enter this name here for this console, you cannot pass. So let's maybe ask a question. And maybe our question is, and we're expecting an input. What is the result of 4 plus 4? Maybe let's say we're asking somebody what is the result of 4 plus 4, right? So let's save it in a variable called answer, right? So now we can then collect print answer, right? Then it will ask us what is the result of 4 plus 4. If we pass 6, it will print answer is equal to 6. Now is 6 the correct answer? No, but then at least that's the code we've written, right? And it is printing answer. Now a way to revise what you learned, let's use if statement. Say if answer is equal to 8, so what do we print? We print correct, right? If answer else, we know that it's two ways in math. There is nothing like, okay, there are a few times where if you're looking for some if you're solving some equations, you have more than one particular answer that can fit in, right? For example, if you're solving quadratic equations, you have two possible answers, right? And if you're solving it's not even always, if you're solving higher degree equations, you always have more than one answer that can fit in, right? So here, but when you're doing this normal math now, I mean normal arithmetic, is only if it is two in Nigeria, it is, even in China it is two. So some of you that studied at another courses, I don't know, sorry. Okay, so what do we, let's just incorrect, right? So we'll just tell the person to try again, something like that. Oh, don't mind me, my T is in small letters. Try again. Incorrect. Try again. So let's run this again. Let's ask the person. Let's say the person enters 6 to tell the person incorrect, right? And run again. 8. Correct. You can see that 8 is not correct. Okay, let's try this here. Let's print answer and see. So what we collected, the answer here is collected as a string, but what we are trying to equate it with here is actually an integer. You can see the value of answer here. When we print an answer, see it now. Type of answer. If you print type of answer, it gives you a string. And if you try to print type of 8, let's print type of 8, gives you an integer. So we're trying to compare an integer and a string, and those two are never the same, right? So see it here. String of 8 is equal to 8. Let's see. Tells us false. So I'm trying to explain to you something now, that whenever you use the input command, whatever result it collects for you, whatever value it enters, it is collecting that value as a string. If you want to use that value as a number, you must convert it to a number. Now you can come back here and after this, there are ways you can mitigate this. So you can come back here and then you can say, you can change the data type of answer. You can say answer is equal to int int answer. So what int will do for you, sorry, you wrap this. Int is also a function. We call this a type. Is it type changing? Um, please forgive me, I forgot the terminology. Um, I think, is it typecasting? I think it is typecasting, something like that. Right. So what it does is that it converts your answer from just answer to from the string, right, to an integer. That is what the int function does. It converts values from either strings or from integers. Sorry, from strings or from floats to integers. So other ones we have like this for changing the data type is we also have string str. It also changes to string. If you use str to change the value to a string, you can also use floats to change any value from an integer or from a string to a floating point number. And when we say floats, we mean, I believe you know all of these things are not new to you. I mean the floats, strings, or integers. We spoke about data types in week 1. That was what we spoke about. We spoke about string data types. We spoke about integers data types. We also spoke about floats, where we have points, right? Floating point numbers. So all of these ones have um, they have they have functions that can change other data types to that data type. So for the integer, it can change the data type of an integer to a string. Right? Sorry, to it can change the data type of a string rather to an integer, and then the string function can also change either from a float or from an integer um to a string, and then the float does the same, right? So that's that. That's why we would do that. That's why um we would convert. So what we'll do here, let me just add the code cell here. If instead of having 8 here, um let me do this int, then we have 8 as a string here. What it will print the value now, not as a string but as an integer. And if you don't agree that that has happened, you can use the type function. You can wrap it around the type function, and you can see that it has changed this value now like this to an integer. So if you like, let's take out this value so that they don't look too long. I can just enter x is equal to this int 8, right? Then if you run this and you print type of x here, it should be able to display an integer. So what we are just trying to do is we're trying to show you different ways you can be able to change values from one data type to another, and you will need this. I might not have a special class where I will teach you how to convert to strings, but from this class I expect that you do knowledge transfer, right? Transfer this knowledge to you to solve that problem that you might have. So now here what we just did is that we converted the data type of an answer to what, to integer, and we studied again in the same with the same variable. So this will just update this particular variable and nothing more, right? So let's run this time around and see. Let's enter 8, and we can see our answer is now correct, right? So I took this time to explain this because this mistake now can keep you up awake at night. It can be the only reason why you've not slept for 2 days. This small error now, if you don't convert data types to the appropriate types that they should. And as a data analyst, data scientist, or engineer, data types, understanding data types, integers, floats, strings, all of those things are non-negotiable for you. In fact, as you begin to go deep, we'll start talking about floating points, the number of precision. We'll start talking about precision, right? We have floating point, we have 32 digits, floating points numbers, we have 16 digits, we have 8 digits, we have 4 digits, right? We have 64 digits. So we have all of those, we call them precision, but don't worry, that's not for this class. This class, we're just learning user input and how to convert the response we have received, to um, the appropriate data type we need it as, right? So we've seen in 2 ways how to collect data from the user and print it. We've also seen how to use it together with our if statements, right? So this is not a new concept entirely. The only thing we are introducing to our old codes is just how to use the impute function. That is the only thing we're introducing to our old knowledge, right? So if you read through this, it will tell you a lot about what I said earlier, how programming is not all about writing codes, but writing codes that end users can be able to interact. And in the real world, that's how programs are. I don't think there is any app that you install on your device, except some apps that really do not require your interaction. You just need to install them, and they work behind the scenes. And those ones are not even users. Mostly, those ones are just codes. You just write them, and you don't have to install them. You don't see them in your app store, because any app you see in your app store maybe require your human interaction, right? So, how the input function works, of course, if you read here, you're going to find out more about that. And then writing clear prompts, of course, you can see this is what we call the prompt now. You are writing clear prompts. Please enter your name. It's better than, I think, please enter your name and name. I think are almost the same. It depends on the context, right? So, but your prompt should be clear. If you want the people to enter their names, starting with the surname first, enter it here. Please enter your name, surname first. If you want the people to enter their name, what do you call it now? If you want them to enter their first name first, you do that, right? If you want them to enter their date of birth in a certain order, you also do that, and you explain to them how they're supposed to enter it, right? So you can see we've done that. Now you can see other things like promptings. Here you can see different prompts in different lines. Here is just the first prompt is, if you tell us who you are, we can personalize messages you see. So the second prompt goes as, what is your name? Now this plus or equal to, what it does is that it takes this prompt, then it adds it to this prompt, right? Adding this extra line here. That is what the dots this guy does. Okay, somebody dropped a message. Okay, this is good. Ayobami, that's good. Ayo. Okay, so just if you get to this point, just try this code and then see what the code does, right? I'm not going to, you're no longer, I don't think it. If you have this x is equal to 2, I'm just going to use this example. If you print x like this, answer you're going to get is going to be 2, right? Now, but what if you decide to do an increment, which we're going to see later? If you do this, x plus equal to 2. If you do this, what happens is that it takes the original value of x, which is 2, it adds 2 to it. Now, if you print x, what will x be? X will be 4. You can see that. So we call it an increment operation, and the same thing with strings. So if you do this on strings, it will take this first string and it will add it to this string. And it is not going to be a result of addition like in numbers. It's just going to continue from where this guy stopped. The only difference now is, you already know what this slash n stands for. It's a new line. So if you're printing it, it's going to cut off this particular point to a new line. Just run the code and then see what it gives you. Then using int to accept numerical input, you can see we actually did that, right? We used int to accept numerical input. And you can see in the examples, they tried to use just the input with numbers, and you can see we had issues, right? And then here they use the int, age is equal to int age. Mind you, you can use this int to wrap even the input function from here. That's looking very, very, I didn't want to bring that up. But let me see, let me just do this here. X is equal to, let's do input, um, let's do X like this. So let's try to run this. This will ask us the value of X. We enter 2, nothing happens, right? It asks us the value of X. Now, let's see first number. Let's just do something that will just add 2 numbers. Collect first number, collect second number, um, second number. Do this. Okay, so we are first number we're collecting is 2, second number is 3, of course. Now, if you come here and you have this print x plus y, let's see what happens. 2, 3, it gives you 23. Because as far as it is concerned, what we did, okay, I don't think I shared this with you, but it is called concatenation. Concatenation. Where do I put this? Concatenation is the result of adding 2 strings together. And we just finished seeing that these guys, when we are running this, it sees when you use user input, whatever it is that you enter here, it is converted first to a string. That is what the user input does. So what can we do? We can convert this guy to an integer even before we don't have to come here and then have this x is now equal to int x. We can do this, of course. And if you try to add this to throw an error, right? Because you're trying to add an integer with a string, it will throw an error. It doesn't understand that kind of calculation. But instead of doing that, let me take that out, right? And why that is happening is because we converted x to an integer and we didn't convert y to an integer. That's why we had that error. It was not because this method generally gives an error. So what we can do is that we can wrap these guys, both of them, from here around the int function. And why are we doing that? Sometimes you might be writing codes and then you might just need where you have so much lines and you don't want to have to be doing all of these guys on a different line. So you can do everything on one line, right? And of course, don't forget the rules of Python, right? If you remember the rules of Python, um, if you dare run a code according to rules of Python, if you dare run a code, sorry, okay, what was I thinking of? I was talking about PEP 8 guidelines or design of Python. We spoke about simplicity, right? Um, let's just do this. I think import this gives us, yeah, you can see simple is better than complex according to design of Python. Simple is better than complex. So if this one will look complex to you or to the people that you're going to interact with, it's better you do it like this, right? All of them still work. But if all of you will understand, you can do this. This is also better because you get to convert everything from the input line. Then if you run this, if I do this 2 3, what do I get? Now I get a result which is 5, right? Beautiful. So we've seen clearly how to take on what do you call it now? We've seen clearly how to take on our this. We've seen how to convert integers and different this one. We've also seen the modulo operator from week 1. I think for the reminder, the modulo operator just tries to convert these guys, right? 4% 3, right? So if you do 4% 3, it tries to return the remainder when 4 is divided by 3. So 4 divided by 3 will be 1, remainder 1. So it will return the remainder of 1. 5% 3 will be 1, remainder 2. So that is why the answer is 2. So we did modulos. I think even over the last 2 weeks again or 3, we still saw modulos again when we were trying to get even and odd numbers, right? So that's just a revision of modulos. And then, so here is just a simple code to check if your number is even or if it is odd, right? So if you perform a modulus operation between the number and 2 and then the result is 0, you know that the number is what even and else the number is odd. And I'm not going to run this code for you. You run it in your practice. If you don't run it in your practice, you're going to see it in your exercise, right? So I don't want to think if you've been in this class before, this is going to be an issue for you to be able to carry out. So what this will do is that it will take the number. Remember, you have to convert the number to a number. Have the value you've collected to a number, and then here you just do the number percent 2. This returns the remainder, and if the remainder is 0, the number is even. Else the number is odd, right? So you have your first set of exercises. Now I'll just introduce while loops and then we close for today's class, right? So I'm just going to introduce how while loops are different from for loops. So let's see while loops. Let's see while loops. Now, so the while loops, like I told you, while loops are infinite, right? And if you don't do anything about while loops, now I'm going to do something that will make us break our code. I don't even know how we're going to do that, but we're going to do it either ways. We're going to break our codes. If your computer is not strong, please don't try this. Try this on your own. So we're going to introduce while loop. Now, for while loop, while you try to check while an answer is this, while a condition is met. Let's write the structure. Let me change this to a markdown. How do you change it to a markdown? You can just come here, select markdown, and I can just write. So while the structure of while loop. Let me do this structure of a while loop. Because if we understand the structure, it helps us a lot. So here is while I don't even know if this will work. While it checks condition. Remember when we're doing for loop. I think I need to bring in for loop here. While then the condition, then of course you have your lines of code, or what do you call them? What should we call them? I don't want to call them lines of code. What is a better name? Call them block block of codes for your code block, right? So here is what you do. So while then you attach a condition to it, right? Right. You know, remember the for loop for then it checks for condition if the condition is true, right? So for x maybe in something, right? It checks to check what it does. Let's say we have these numbers. Let's just create a list. 1, 2, 3. Yeah, that's okay. So we can say for x in numbers, you can just print your x. So what happens each time this for loop comes back is that it takes the first number, and so it, as long as there are elements in this, it will continue to run. While the while loop, what it does is that it actually, if I'm going to use this to do the while loop, it's going to be different. So I'm going to do something like this. I'm going to have while I oh, let me use this example. Let's do this range so that we're not bringing a list for now. In range, let's say 10. You do this, you're going to have 0 to 9. So for while loop, you're going to do this while, right? So instead of passing in the range function, we can actually do something. We can give it the starting value, right? Let's give it a starting value of I. You can either use I or start or any variable, but let's just call the number I. Or you can call it X. Let's give it X since we've been using X. So X, the starting value is 0. So while X, is less than or equal to or is less than 10, because we don't want X to be up to 10. What do? We can try to print X. Now let me explain to you what will happen here. So you've already assigned a variable here that X is equal to 0. So it will come here, 0 is less than 0. Of course this is true, so this condition automatically is true, because why? X is less than 0, right? So sorry, 0 is less than 10. And so if since this condition is true, it will go and print X. But note what will happen this time around. If I go ahead to just print X, each time it comes, there is nothing modifying the value of X. So each time it comes, X still remains 0. So if it comes here, X is less than 0, what happens? And then if X is less than 0, then if you try to print, sorry, sorry, I take that back. So X is equal to 0 and 0 is less than 10. If you print 0, you still come back here again. X is the same thing as 0. It has not changed. It has not increased or decreased. So it will still come back here and say 0 again is less than 10. The condition is satisfied. You still carry out this operation. You still come back. So this will now give you a loop that never ends. Let's run this and see. I told you, if you don't have a powerful computer, don't try this. Let's run this. Now you can see the zeros have continued to be printing from now to infinity, and this is still running. As you can see, I'm trying to scroll, but my computer is almost freezing. You can see what it has been doing, right? So it has been printing zeros and it has not stopped. And you can see my computer is even freezing now, right? So that's what you get when you do that. And how do you stop this? You can come here and stop the code. That's if it allows you to stop the code. You can come back here and stop. You can see it's telling me to exit the page, but then I'm just going to go back here and just stop this code. I think this is the Windows PowerShell I'm running this. Okay, this is it here. So I'm just going to use Control C to stop it. Interrupted. Control C to stop that. So if I do that now, everything has stopped. I can go ahead and restart this guy now. Um, Using my command Jupyter Lab. So you can see I had to come and stop it, right? I had to come and stop it. Wait, please. So let me just exit the page. If not, it will continue to run. If you try it in your computer, what you're likely going to be hearing now is your fan. Your fan will be turning as if as if it's masquerade that is pursuing it, right? Okay. So that is what happens here. Now I've just added another Jupyter server. Don't worry, if you watch the video of how we install Jupyter Lab, you would understand all of those things. Okay, so I think we are back. We are back now. Just that you can see even the outputs here have not been displayed again. Now, what can we do to mitigate this error? We can introduce something that can break the loop, right? We can introduce some condition that can break the loop. So what condition can we do? We can increment. We can do an increment operation, right? Increment to to break loop or to stop loop. Oh, sorry. You know what? I'm not going to use grammars a lot. So what the increment operation will do is that it will continue to increase this number, up to 10, until it will get it up to 10. Once it gets up to 10, 10 is not less than 10, then this loop will break. But as long as this condition remains true, this while loop will never stop. So that's why we'll come here and then we'll come and say x equals to x plus 2. This is also the same thing as what we did earlier. Remember this? Where is this increment operation? This here is the same thing that we're doing, right? It's the same thing. Okay, let me increment it by just 1 so that it just increases after 1, right? So this guy here, x equals to x plus 1, is the same thing. Okay, x is not defined. So let me say x is equal to 0. I just want you to see what will happen. X equals to x plus 1 is the same thing. Yeah, I didn't print x. It's the same thing as saying as Python shortcut plus equal to. So when plus comes, I don't know if equal to plus works. Let me see. Equal to plus. Okay, it works. So if you have equal to and plus at the same time, Python just increments. It takes it as an increment you're trying to do. And the same thing with minus. If you just bring in minus here, it will take 0, subtract 1, and then replace the value with the result it got. Right. So here, x is actually 0. So it takes x as 0, subtract 1 from 0, that is 0 minus 1, that will give you a negative 1, and then you print the value, it gives you minus 1, right? Beautiful. So that's what we're doing here. What we're trying to do here is we're trying to increment this from 0 now. If it comes here, it prints 0, then it adds 1, then it continues. So depending on where you want to add the increment operation, if you want the increment operation to come before the printing, just know that the results are going to be different. But let's do this now and see what happens here in this loop. Now you can see it printed. When it got to 9, it stopped. Now if I decide to bring this increment guy from here to this place, bring back this guy here. If I run this, you find out that it will start from 1 and get up all the way to where? All the way to 10. Now the first one I did, it actually printed from 0 to 9. Now it printed from 1 to 10. Right, let's see why it printed from 1 to 10. Let's analyze our code. Let's read our code and then see why it will do that. So first it takes the value of x as 0. Now the while loop, it checks, is 0 less than 10? Correct. Then you bring it here, right? Then you now increment 1 to it. That is why it will start at 1. So all the way until it gets to 8. Let's assume now, okay, let's do 8. Yeah, let's do for 8 now. When it comes here, it checks 8. Is 8 less than 10? Yes, of course. Now it comes here and then it increases 1 to 8. That gives you us 9. Then it prints 9. That is the 9 we have here. Then it goes again. It adds 1. Remember, it added 1. Then to come back here. 9. 9 is 9 less than 10? Of course. It prints 9 and adds 1 to it. And then prints that. So that is why we have up to 10 here. And then it comes back here to check. And then it checks. Okay, so now the next number is 10. Is 10 less than 10? No, 10 is not less than 10, right? How do you check that? I don't like people who cram. I like people who check. Let's check 10 less than 10. 10 is not less than 10. It gives us false. So once the condition becomes false, the loop breaks. Once the condition becomes false, the loop breaks, right? So that is how that is how while loop works. So depending on where you add the increments, if the increment is here, it's going to give you a different result from when the increment is here, right? So why am I telling you all of this? Is because I don't want to kid you as programmers and tell you this is where the increment is supposed to be. No, 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 no. Where you put it, it depends on the output you're trying to get, but you can still maintain one way. For me, I always carry out the operation before I do any increment, because simply if I want the number to start from 1 to 10, I can just adjust this one, make it 1, and then either make this 11, you can either make this 11, it will still give you from 1 to 10, or you can make it 10 here, and then here you can make it less than or equal to, so that it includes 10. If you don't add less than or equal to, it does not include 10. If you have not forgotten your inequalities, if you do this, you still have the same result. You can see flexibility in approach. So I can do it this way. It means five of us can sit down, we'll still have different approaches to doing it, and we'll still get it correctly, right? So, um, but I just feel if you're using it, I think the less than operation, I think it does a better job. I don't know. I think it does. But don't worry, you can still use this. It still works. And at this level, we're just trying to explore different options. When we start data analysis proper, which by the way, I'm going to give you before you graduate, I'm going to give you like a week's data analysis. We're going to do data analysis with you guys a week for 1 week. Then you're going to see what data analysis looks like. We're going to try to analyze, even if it's one data set. Then when we do so, um, you would have a sneak peek. You see how all of these things are put together. And when we have large data sets, for those of you who further do data analysis, you find out that there are operations that will increase the time it takes for you to carry out that a particular analysis, and there are operations that if you do, they speed up your operations, right? So don't worry, you have all of that taken care of. You have all of these things I'm saying, you have all of them taken care of already. As you continue to go ahead, you continue to see, okay, so why we prefer this way over this way, right? So as you can see, this the example looks similar to what we did, right? And you can still study that. They initialized a particular number called current number, right? And they use the current number, with while loop and then an increment operation coming after the print statement. I remember I made mention that this can come before or after, depending on what you're trying to achieve, right? Okay, so basically, this is also you making, you know, this is you letting the user to choose when to quit by receiving one particular statement or the other. Now you can see where while loop and user input are coming into play, right? Together. So here you can decide. Imagine in a case where you are you're running kind of a game, or you're playing a game on your PC, and you see things like, do you want to quit now, or do you want to try again, and all of those. So if you see anything like, do you want to quit now, it means there was a loop. Anytime you press no, the program is going to loop and run again, right? So we're going to write something close to that, right? Let's see that at work. So let's say, let's just call this answer. Let's leave it as blank, or you can call it no. Then we can have while answer is equal to no, right? While answer is equal to no, let us ask the user. Let's do this instead. Let's modify answer. Or let's do something like let's just print this statement. Let's just print something here, right? So here we'll just tell the user something like since if the answer is equal to while answer is equal to no, let's tell the user uh, game over, something like that. Game over. Let's assume the game is over, right? So we'll modify this. Now we'll ask the user using our input statement, do you want to quit? Right. So let's run this and see what we get. So, oh, okay, this is the game over. Money and spellings. So, do you want to quit? Let me press yes. See what happens. So you can see that once I entered yes as a response, what happens? The loop terminated, right? So let me try entering no. And then you also see the downsides of this. If I enter no, what happens? The game stops, right? Okay, so rather the loop continues, right? As long as I press no, because the question is, do you want to quit? And I ask no. But you can see it's actually me using a particular logic, right? If the person enters anything like capital NO, of course this will quit because it is not the same thing as this, right? Then I taught you, okay, you can add dot lower here so that you can receive any kind of no, right? You can see any kind of no you want, it will still be asking whether you want to quit, right? Now, what I also want you to see, the downsides, let me just put a yes and go. If you run this, right, if you enter anything, even if it's just y, it will quit. right? Even if you enter anything like 1, 2, 3, it will still quit. Anything you enter will terminate the program, because your condition is that is only when the answer is equal to no that this loop will continue. But when the answer is not equal to no, you know, the loop will fade away. So that's another person's approach. Another person's approach will now come and be okay. So I'll just have this and then come back here. I will just say while answer is not equal to, you know, it's not. Remember the not equal to. I'll come and put not equal to yes here. Okay, let me put y yes like this. So it is only when answer is not equal to yes, you know, continue to loop this program. Now, why am I saying this? Let's run this and see. Do you want to quit? If I enter yes, what happens? It quits. But if I run this and then I enter no, do you want to quit? No, it continues. Capital no, continues. Every other thing will continue to make this loop run. The only thing that will make this loop break is if the person enters uh, anything that is not yes. But once the person enters yes, the program stops. So the only thing that can break this uh, this particular while loop, the only thing that can break it is when this condition becomes false. And the only time this condition becomes false is when what the user enters. If you take the dot lower, if you apply the dot lower method, is not equal to yes. If the person enters this, watch and see. The person enters yes with a space, it's still not a yes, right? Still not a yes. Except if out of your benevolence, you now feel okay, so I can actually do something for these guys. You can come and add. You remember the dot strip method here, then you run it. So that even if the person enters yes with space, it will still quit. So a lot of the apps you use now, you're beginning to understand the error handling approach they've been using in the apps you have been using in your phone. Sometimes you find out that you're trying to enter your password, you enter even with spaces, to the right or to the left, it still works. There are sometimes where you just do some things that normally it's not supposed to work, but it still works. It's because these people are trained to understand error handling, right? So that's why we have that. Anyway, forget about what we're just trying to do is we're trying to give a user, we're trying to allow the user um the ability to be able to end a loop by himself. So there are majorly two kinds of statements that can affect how a while loop runs. One of them is the break statement, and the other one is continue. Break and continue. And of course, let's pick the first one, which is break. So just like the word implies, break. Imagine breaking an egg. Imagine the time break up in a relationship. It actually means that the relationship has come to an end, right? So that's what break statement does to a while loop. It's actually a heartbreaker, right? So it breaks always the heart of a while loop. Put it that way. If you put it that way, you're not far from the truth, right? So that's what the while loop does. Sorry, that's what the break statement does in a while loop. It terminates the while loop, right? So let's see an example. Let's pick up this guy. While let's use the true statement. Now the true statement is a constant, right? It's the true is a constant. Just like we have two, we have one. We were able to establish that in our former classes where we say true is even one, right? And we also agree that if you have any statement like let's say while x stays below 10, what happens here is that Python checks this as a condition and it evaluates it whether true or false. And then this while decides whether to carry out to run the lines of the code beneath it or to skip, right? So if you use while true, it means you're telling this Python is already true, just run it. There is no condition to check, right? So if you do this, you will need to provide a way for whoever is using your code to be able to exit, right? So let's say you're asking them a question, right? Yeah. Let's say you're asking them a question. What is the value of 4 plus 4? And then you said it's equal to, right? Answer. Thank you. Correction. Now, remember, we need to int our answer. At least since we're using an integer, right? If we're using a float, then we'll convert. Oops, what am I doing? This is int. Beautiful. So we do this. Now we must provide a way to quit. Already from what we've learned so far, you know that if we don't quit this, then of course we are sure that this is going to continue to loop even when we enter the right answer. Right? So we can just come here and just add the little if statement here. If answer is equal to 8 now, what does it do? Break. So this break will automatically terminate the loop. And this is not just because we're using while true here. Whatever command you use, you can decide to break the program at some point if some conditions are met. I mean the loop rather. So, oops. Let me check the carbon. check. Okay, let's run this. Okay, invalid is 4 plus 4. Okay, this is input. Yeah, just statement 4 plus 4 equal to 1. No. So as long as you enter anything that is not it, this guy will continue to run. Sorry, as soon as you enter it, it breaks. Beautiful. Let's say your password now is equal to 1 2 3 4 5 6. I put it as string so that I don't have to suffer and convert it. Right. So you can just come here and say while true. Now it means you're going to ask the person of his password. Right. So let me call this uh PSWD for password. That is the user's, or let me ask user input response or something like that. It's equal to input. Just follow me gradually. Password. Right. So here now once you collect this input, it's time for us now to use an if condition to check, right? So if resp is equal to password, then what should happen? The loop should break. Else the loop will continue to break. You don't even have to add else. The loop will continue to break. Right. So once the loop is running and then it meets a break in its front, it knows that it's supposed to break. Right. So let's run this password. Let me add QWERTY. Bam. 1 2 3 4 5. Bam. 1 2 3 4 5 6. Yes. Or maybe you can then add something like can then add print something like welcome. Right. So um i- imagine now that you're able to use this to create like a password authentication system where someone enters their name and the password, right? Then you try to authenticate. So you can actually do that. In fact, let's do that already. 1 2 3 4 5 6. Right. Okay, welcome. So let's build up on this. Let's say username is equal to omi, and then we have password is equal to, just go ahead and 1 2 3 4 5 6. Right, ladies don't like password that will stress them. So while true, just run this resp like we have there is equal to, just collect. Now this resp is just to collect our user input, right? So first of all, okay, let's to a username, but I don't want to use a name. Okay, let me use underscore name so that it does not replace this guy. It's equal to, now we are going to prompt them to enter their username, right? Going to prompt them to enter their username. Then this one, I also do this, right? So this will be password, right? So it will ask the users of their username and password, right? So we'll just come here and then we can use one of our statements. If username, this username is equal to username, like this, and then the password. Remember, the password and the password have to be the same, right? And I hope you've not forgotten. Um, I hope you've not forgotten how you used to log into your email or any other place that needs authentication, right? Break, or before break, let's print something like access granted, right? So it will break. Else, if this is not true, you can decide to add an else statement, right? Even if you don't add an else statement, this will still wrong because the program will break at this point and will not even check anywhere, right? You can decide to add an else block, and the else block is just to say we're just going to say print access denied, access denied. Right, so let's run this now. Let's see. We have so username, money, password, pass 1 2 3 4, access denied. Right, so you can see it is coming back to tell us what username. So since we have access denied here, let me add a slash, backward slash n here, so that it gives us like a new line space, right? So let me enter the actual guys we have. 1 2 3 4 5 6. and you can see access granted, right? So if you run this now, you should see that there will be a space between every successive failure, right? So that's it. You can go ahead and make this better. You can add dot lower to catch some errors, whether or not the person enters his name with small letters or capital letters, you should be able to recognize. Maybe the password can still remain case sensitive, or the name should not be case sensitive. I mean, the username. But either ways, we'll still see how to use this with our dictionary or our list, right? As you continue to as you continue to go ahead. But this is a very, very good authentication system use case. You can see with your little knowledge now you're able to build a little authentication system, right? But this is when already we know the username and password of the person, right? So imagine you have a dictionary now that contains usernames and passwords, right? So if you do so, it's just for you to check if the username exists in the dictionary and if the password of that particular username is actually correct. That is okay. First of all, you check in the list of people you have. Does that okay? Let's do that. Let's do that. I don't like long grammars, so it's just this same thing we're going to copy. But this time around, we're changing it, just making it better. You can call it version 2 or version 3. So instead of having just names here, we're going to do this. We want to have users. Call this. Somebody actually told me that she liked this name of users. If you're watching this, I think I'm dedicating this part of the video to you. And then so we're going to have Umi as the key, and then her password will be 123456. And let's have another one. Money. Let's have my password as what? Pass. And let's have John. Oh, so why do I name with 1 liters? Okay, let me do this. Let's have John and pass 112. Okay, so we have this dictionary now with these people, right? You can see each of them has his own password and username. So the first thing we're supposed to check is two conditions first, right? Now you can use an and statement like this, or you can use this. You can come here. First of all, let's do an if. If um username first, this username that we collected from the user. If username is in users dot keys, right? So if the person enters, it will check in the keys. Remember, these are the keys, these are the values. If you've not forgotten your dictionaries, so if username is in user dot keys, then you should go ahead, to run what we want. Now you can still go ahead and now to check. Now if now we'll add another if condition again. This is called nested if. So first of all, it will check if the username exists in this case. If it doesn't, it will skip, you know it will skip to the next to the else statement, to the else block. Now um if now we're going to add another if. Now if the name exists, quite all right. Now we want to add another what do you call it now? We want to add another condition now to check if the password of that person, because it's one thing to get the name correct and the password wrong. So we can come back here and then you remember this will now be users with the username. Remember how we used to access keys? If users.username, we want to access the keys. You remember if you have users as this, let's just revise dictionaries a little. Uh, Come on. Okay, so if I have this, right, how do I access the password of Umi? I can just come here. Then let me copy these users, put Umi here. If I put it, I have access to a password, right? Correct. So we come here and then we say, so if users with this username, so this username will either be Umi, Mani, or John, depending on what the person enters, right? So this will be a string. So if users with this username, if their this one is the same, is correct as password. And where did we get this password from? Is what the user entered here. So if the password that the user entered, you remember this is equality, so you can start with password equal to. So if this password that the user enters is equal to the password of the person in our database, then we can now go ahead to print these guys. Print simply print, okay, here you can simply go ahead here and print, what do you call it, access granted, right? And then we can come and print here. Apart from access granted, I think okay, we break the statement, right? Break. Of course, we bring in the break statement, rather break the flow. So I let me just comment these guys out so that they don't run as part of our code, right? So let's run this password and see. Sorry, the program. So it is asking me of my username. Let me enter money. Then let me try entering the wrong password. You see, to tell me what access denied. So let me enter again money. Let me enter pass. See access. Oh, access denied still. What is wrong with our code? Oh, okay. I think I understand. So this is not descriptive enough for access denied. So let's try something like access denied. Let's print another thing. Um, username. Oh, let's just add it in one line with the previous one. You can add it better. Add the username. Oh, password incorrect. Okay, I'm already running something. So I will just come here and I'll just type money, and that's why it's running. Is because it's seen money that I've been entering this with capital small, sorry, in lower keys, whereas what I stored here is what I stored here is in title casing. So I can just come here and enter this, and then I have pass now, and this should work. Access granted, of course. So why am I still having this here? Access granted. I'm supposed to have an exclamation mark. Don't worry, programming is actually an iterative process, right? Okay. So you can still even add something to this. You can add if the person wants to try again or not. Oh, you can enter here something like try again. So this slash n should not be here. It should be here before. If not, it's going to give us some spaces we don't like. Right? Then we have that. So there is also another thing you can do to handle these errors, right? Regardless of what the user enters, right? You can lower everything here. You can come here and say if username in, yeah, dot keys. So you can actually use dot lower here. You know, okay, let's even take this out, dot lower. Remember what we did the other time? We created something like when we were trying to test, when we were trying to create a list from another. I think we did something like creating a list that has where the names are actually lower, right? So you can actually create another list, or you can create another dictionary where all these keys are used as lower keys, right? And you can also come here and do some error handling. Well, don't overthink it. Just build it and let it work first. And I believe you'll be fixing it as the codes are breaking. So sometimes you see some people's code is up to 8,000 lines, some people 6,000 lines. I think I was listening to some people talk about their code base, and they were like the code base was up to like 3 million lines, if I'm not mistaken. And so that shows just one thing. That shows just one thing. And what it shows is that those people did not just wake up one day and build 3 million lines of code. They started from somewhere, and then they started thinking, what if this? What if that? Right? So forget that you're writing 10 lines of code or one line of code and then it's giving you results. Let it just give you results. As you continue to grow, as problems will continue to come, you continue to be fixing up the problems. And sometimes it is as a result of fixing problems that your codes will now increase in size. But don't worry. Don't worry. Right, so this is not scary. This is just us running very basic codes. Okay, so let's round up. I think we also have an exercise similar to this to try. So we use the break to stop, right? And then we also have a continue. So this continue is not the opposite of break entirely. It's a cousin brother, if you like. So while break will stop the loop, will terminate the loop entirely, continue will not terminate the loop. It will only suspend the loop for the particular running it is running. For example, so what a loop means is that these guys here keep running over and over again, right? Over and over again until we decide to break this program at some point, right? So for continue, once you hit continue, it is not going to stop running entirely. It's not going to stop running entirely. So what it will just do is that for that time being, it will skip for that particular running. So if it is continue here, it's not going to run this guy. It's going to go back and start again from the beginning, right? So all of them have different ways you apply them. Now take for example, now you want to print, you have a set of numbers, but you want to print only odd numbers, right? So you can just come here and you can just start from, let's enter some number. Let's say you want to start from 0. So you can come here and then start with while I is less than, right? Let's say you want to do from 1 to 10. So let's include 1 less than or equal to 10. So you can come here and do print. Okay, first before we print, let us check our condition to continue, right? Let's do if this I that is coming, if this I is an even number. How do we check even numbers? If you've not forgotten, we use our percent symbol, right? Percent 2. And we say if this is equal to 0, then surely this is an even number, right? So if this is an even number, you can tell it to what, to print I, right? And else, let's bring this backward. I'm not even going to an else statement here. Print I, then if not, then you continue. Okay, so I don't think I'm supposed to put this here. Let me add. Okay, let's try. Let's see what we want to do. Print I. Now if I add continue here, now what will happen is I'm not going to get what I want. So let me take this backward. So if I percent 2, right? So this is now telling us that this number is even, right? So if what we wanted to print is an even number, we'll just go ahead and put if this is not equal to an even number, right? Then continue. Else you do what? You print. I don't even want to add the else block. Else you print I. So this is what will happen. Let me explain to you what will happen before the program starts. So while I is less than 10, it will pick 0. 0 is less than 10. It will divide 0 by 2, which will give us 0 exactly, right? So this guy now will be false because um, if you divide 0 by 2, it's going to give you 0. So this if condition will not run. And so it will print I. That is how, so it will print 0. Now we need to add our increment operation, right? We need to add our increment operation. And then this will now be, if, sorry, we'll just need to do I plus equal to, if you've not forgotten, 1, right? To increment I by 1. Then we run this. Now this is what will happen. So this will only be 0. So why did you just print 0? Stop. Okay. Kind of surprised. Didn't I break this code? I plus equal to 1. Supposed to get to this place and stop. Hope I've not annoyed the codes. Okay, let's go over this code again. So this checks to see if I is less or equal to 10. Of course, 0 is less or equal to 10. So if this percent 2, that is, if this number is an odd number, right? So it will just skip the number. So continue is like skip for that particular, just skip, go like let's skip for that particular number, right? So continue, you can just see that as a skip operation. And then if it comes here, it adds 1, then we can continue. So hopefully, I don't know why this guy is not up yet. But let me try to interrupt the kernel. Okay, so let me run this. Error, session line number was not unique in database. History login moved to a new session 205. Okay, is there anything wrong with this code that I'm not aware of? Okay, keyboard interrupt, of course. So let's say I have this. Let me start from 1. I plus equal to 1. Yeah, then I goes back as the next number. Okay, I think something is wrong somewhere. You know what? Let's take this. Let's try a simpler code. Okay, there's definitely a problem with this code. Okay, closer look. So our I is equal to 1, then while I is less or equal to 10, now come here. If this number is even, if I that it picks is even, what happens? Sorry, is odd rather. Or if you like, you can come back here and say equal to 1. It's still the same thing, right? Because odd numbers, I'm not saying that is a guarantee that they are odd numbers, but if you divide a number by 2, there are only two possible reminders you can get. Is either the remainder is 0, I mean any integer, you divide by 2. There are only two possible reminders you can get. It's either the remainder is 0 or the remainder is 1, right? So, I mean, this still works. I'm kind of surprised at how and why this code is not running. Is there anything we're getting wrong? Okay, you know what? Let's put this in an else block and see. But I will be surprised if this runs now. Same output, I guess. Let's add another cell. Let's do this all over again in another cell. So let's give an initial number I is equal to 1. To start here, while I itself is less or equal to 10. Let's do this less or equal to 10. All right. So we come here, and then before printing I, we'll check now I if if I percent 2, right? Percent 2 is equal to 0, right? We can come here and then tell it 12 print I. Oops, we didn't add an increment operation. Yeah, this will run infinitely. So here we have I plus equal to 1, so that I can be incrementing. Now you can see this worked. So I don't know why this one didn't work. Was it because of the continue? So this is another way to write it, but what we wanted to use the continue is to skip for some certain numbers, right? Wanted to just skip for some certain numbers and then continue. For example, now let's say we want to print. Let me just use a simpler example now. Okay, let's add a simpler example now. Let's just print numbers from 1 to 10. Let's have this. So this gives us numbers from 1 to 10. But what if we want to skip 5 and 6? Right now you can see where continue will come in. Right, so we can now say if number, let's first see how we can skip 5. If number is equal to 5, we will not ask it to print, we'll just tell it to continue. Right, if number is equal to 5, continue, else you print this and then you add 1 to it. And then, okay, I think I know why our guy was not running. We are supposed to add this increment operation here as well. So before we add the continue, we can just increment first. So what happens is that it gets stuck. Yeah. So what happens is that when we come here, this program gets stuck. Now, this for the first time it comes, right? Let's start from if we start from 1. 1 is less than 10 correctly. Now if you divide 1 by 2, it will give you 0 remainder 1, right? And then you're telling it to continue, so you have not modified the value of I, so it's still going back with 1 here, right? So it means here, even before the continue, you're supposed to come and break the loop. I plus equal to 1, do the increment also here, right? Before you think of breaking the loop. So let's do this. Let's run this. You can see this also worked, right? But why is it giving us only 2 6? So let me even run this. Okay, so 2 or 6. This code is actually interesting. Okay, so let's make this not equal to 0. Because here, if we're printing only even numbers, we have 2, we have 4, we have 8, right? Oh, yeah. So why the rest not showing up? Okay. Some codes can still shall have. Okay, so here we just run. Okay, I think I have an issue. Number is not defined. Okay, I. Right, so let's see what this gives us. And you can see this. Okay, this worked. You can see it skipped five here, right? It skipped five. So you can come here and also, if you want to add an O statement, you can also come and add if or a is equal to 6. So it will skip 5 and 6. If you want to come and add 10, you can come and add another O here. I'm not sure if this will work. I is equal to 10. Okay, that worked. Well, to be in a safer side, put these guys in brackets, right? So this first checks this or this before it checks this or this, right? Put these guys in bracket to be safe, especially when you're using, when you start getting to pandas, right? Let's put all of our conditions in bracket so that once they are evaluated, they'll be evaluated with that true or false. So you can see we're skipping values, right? Or if you like, instead of all these or statements, you can just come here and say if I in, you can pass the list of numbers that you don't want. 5, 6. This will still give you the same result, right? So you can see many ways where you can approach problems. You can approach problems from so many directions. And then don't worry about, I know we tried some things and they didn't work. Don't worry about them. Let's sometimes you need to get codes like that that will be a bit naughty. Then at some point in time you're able to fix them and you're like, okay, now I got you. Right. So here before they continue, I think we added one. So I really don't know why this code is not running as it should. Because here we're adding, okay, here we're adding I, not one. Hmm. Anyway, I think I love this. I love this. I love this. So we now see all of the errors we have. Okay, that's great. Um, Now you have your next set of exercises. Very, very easy. Um, Using a loop with lists and dictionaries. This is just us trying to see how what we've learned so far, can come all together. So here you can see that we have a while loop and we have lists and dictionaries. And all of us know lists and dictionaries, except that this time around we're talking about while loop. So just like we use the for loop to run through list, we can also use while loop to run through list. But this time around it might involve just an extra step, you know. Because when we run through a for loop, automatically the loop executes them, sequentially. Immediately it finishes this one, it goes to the next one. But for a while loop, we know already that it will not be able to go to the next element except if we implement something that is like an increment, right? That is like an increment, and then we're going to see several ways to be able to achieve that. Okay, see, I have a list of numbers. Let me call them. Let me create this with the range function, right? List range 1 to 11. If I run this, all of us know what this will give me, right? Except if you've forgotten how to create elements, a list, I mean, with the range function. Okay, so from this result, I'm going to try to run a loop to print each of the elements here in this particular list, right? So what do? I can just pass in the index of the first one. Let me just pass it, which will be 0. You remember we have to pass in some initials to be able to run a while loop. So we can have this here. You can have while. Okay. While I, you know, while I is less than. So how do we know the length of this list now? I'm not using len function, len of norms, right? So while I itself is less than the len of norms, well, what I want you to, yeah, so while I is less than the len of norms, the len of norms here will be from 1 to 10, which will be 10 numbers, right? So this is all saying while 0 is less than 10, right? So what do we want to do? We want to print, norms of that number of I, right? But remember, if we just leave it like this, what will likely going to happen? It's not likely. What actually certainly is going to happen is it's going to come here. The first number is 0, so while 0 is less than 10, perfect. It will print nums 0, which will be 1. Then it will go back again because you've not modified I to still pick I as 0. Repeat this particular operation, right? So that's the intuition behind it. So if you do not pause to add an increment to this, it will just be printing 1, 1, 1, 1, 1, and your computer will just freeze.
Here we increment I plus equal to 1. So when we run this, what do we get? Get 1 to 10, just like we could ordinarily just use. I could use for loop for this. I mean, for norms, you know what, print norm. So you can generally see that for loop was meant for anything like this, right? It was better. You can see how in 2 lines we're able to finish it, right? So this is grace. For loop has the grace for this, right? But there are things for loop cannot do. For example, it cannot handle when we do not exactly know the number of times it should run. Right? That's where while loop has grace for. That's what while loop has grace for. Now you can see here we have I is equal to 0. So why do we have red lines everywhere? Let me run this. Okay, the red lines can learn how to go to hell. Thank you that it's running. So now you can see that while loops we needed to add like 4 extra lines just to get this job done, right? So sorry, 2 extra lines rather. We need to add 2 extra lines, right, to get the job done. So it's now left. It depends. That was what I was trying to say at the beginning of the class. It depends on the problem you're solving. The kind of loop you use should be tailored towards that kind of question. Now, let's go ahead to wrap up. Okay, we had an example from them, right? We are trying to move items from one list to another. Here they were trying to move names of people from this list to this. We know in for loop we can just pick the person here, put the person here, and not even we don't even have to pop this, but we can still do the same thing in for loop. We can try it in for loop. So what do we now do? Look at the example now. Let's say we have we have norms already, right? So let's try to move norms to another list. Let's say let's say we are now packing our goods from norms to another place. Um, let's say we are calling them numbers, right? Let's say someone walked up to us and said, okay, it's not good to use the norms, to use norms as your variable name, so we're copying everything onto norms. Remember, we're not just copying, we are moving. So moving means norms should not be having any element left in it, which means we have to be using the dot pop each time around, right? So um if you've not forgotten, once we use dot pop, right, it returns a particular element. Look at this. If you use norms dot pop like this, it returns an element, right? That is, it will return the element that it removed. Now, now pop again. Remember, it pops from the end, right? It pops 9, right? So if we want to pop the number at the first number, you want to pop the first number. What do? We can come here and use 0 as the argument, right? And then it will pop the first one. And we can still use the same thing because once we remove 1 now, the next one that takes over the index of 1, which is, at position 0 now, is 2. So if we print pops these nums to pop 0, it will remove 2. Yeah. Now this guys will shift. It's just like, I don't know if you understand queuing culture, right? If this guy now is attended to, and this guy is attended to, automatically this becomes the first in the queue, right? I don't know if we understand queuing culture a lot in this country, but I mean, I'm not saying the country in particular. I'm still proud of my country anyway. So but you can see we have that. So that's how it continues. So, but I'm just trying to show you the intuition behind what we're going to write, right? So what we're going to do here, let me reinitialize my norms. Where is it? Just copy this. Let me bring it here. So let's say we have a list called norms, and then from these norms now I want to transfer everything from norms to this guy, right? So we can just create numbers. Let's create it as an empty list. So you see we have 2 lists, one norms and another is numbers. So we want to transfer everything that is here to this guy, right? So we can now use our while loop. Now, while norms, just like this. Remember, I told you something about if statements. If you did not forget, we have if norms like this. If a list, so it tries to check if a list is empty or not. So if a list is empty, it returns a false. Oh, the norms, this condition does not get executed. But if it is true, right, then it happens. So let's see this. Print. Let's do something like list is not empty. Let's do this. You can see it run. So when a list contains something in it, then the list itself, if you use an if statement, it will be executed. How do I put this? It could be evaluated to a true, right? It's almost equivalent to a true. Remember, after an if statement, it is expecting a true. So if it does not get a true, the next thing it will try to check is am I giving an iterable? I mean a collection, right? So it will try to check is the collection empty or not. If the collection is not empty, that is, if it contains something in it, then it's a true. While if nothing is in it, then it is a false. Let us try an empty list here. Then run. You can see nothing happen. It will not execute this code because this is seen as a false, right? So that's exactly what we're going to come here and do. So when we come here, this is what while nums will do to us. While nums, it is just trying to check while nums. It is trying to say it's just trying to check if nums still contains anything in it, right? Because we're going to keep removing elements from nums, but while nums, so if nums still contains something in it, again, if nums still contains something in it, right? Or if you want, some of you can just come here and see while len of nums, while len of nums is not equal to 0. Somebody can decide to come and do this here, and I understand your intuition, right? I understand your intuition, and you are not far away from the truth. If you can think of it like this, fine. Then we can come here and just numbers dot append. So what are we appending now? We're appending what we are removing from here. Or if you like, we can come here and add something like removed number will be equal to nums.pop. So remember, okay, let's use pop 0 so that we're removing the elements from the beginning, right? The elements now are being removed from the beginning, so that it will remove the first one here and add. If we just use dot pop, it will start from the last element. To line them up from 10 to 1, right? So that's why we'll always just come here and remove the first element. So here, remember when we use the nums.pop, it actually returns a number that is removed. So here it will remove a number and then it will return the number. For example, when we saw here, it removed 10, then that was it printed 10 for us. So here, when it comes here, it will remove the first element and then it will assign it to remove number. So what we need to come here and do is to copy this guy, and that's what we are adding to the list. If you like, you can just copy this guy here entirely and just replace it here. That means that there is no need for this second step. But this is more intuitive if you ask me, right? So I just hope that okay, thank God. And here to add an increment operation. Okay, I don't need to. I don't need to add an increment operation because this already handles the increment for me. Yeah, because it keeps removing, not necessarily an increment. It could either be an increment or a decrement. In this case, we need a decrement, right? Because norms, the only thing that can make the len of norms to become 0 is when we keep removing elements. But if we keep adding, right, it will not. Remember, what we're trying to do is to get the loop to terminate at some point eventually. So let's do this. Oh, so it has finished. Okay, so let's try norms and see what norms is. You can see, so it has transferred everything from norms, right? Norms used to be a list of these numbers, but you can see norms now is empty. Now let's look at our numbers. You can see our numbers. So there has been a transfer from norms to numbers. I just took my time to try to explain an intuition to you on why we are attempting this using this, why this approach works. And I tell you, you can still come here and then remove this guy and just put norms, right? And then run this. It still works. Can you see? It has still done the job. And this is probably faster than the previous method, right? Because in the previous method, it involves first using a function to count the number of elements in the list, right? Then going ahead to be able to equate the digits. That's a lot of things. But if you're using the while nums, it will just check if the list is not empty, right? There are so many ways. Just try and find out if there is any other way you can go around this based on what you know already, maybe based on what we have taught you so far, or based on your experience, right? If you can come up with something, I mean, that would be pretty cool, right? Okay. Forget about this example. I think we were trying to look at norms like this. So you can see that now if norms print list is not empty, right? And you can see that, let me add an else list is empty. And let's run this and see. So you can see list is empty now. Very good. Okay. So let's, I think we're rounding up. That is using that with lists now. And we have moved these guys from one list to another. Except that in this example, I think they've been trying to use dictionaries themselves. So we have unconfirmed users to confirm. So we are moving confirmed users to, you know, to this list. So they said while unconfirmed users, you can see now. So what they are trying to say now is while this list is not empty, right? We are popping elements from this list to this list, right? And here they use the dot pop because order does not matter to them. So if order does not matter to you, you can just use the dot pop, right? Remember, this is not, they're not using this for a dictionary. Remember, this is an F formatted string. So this is just a variable here, right? So just look at the example, try it out, see what it looks like. I mean, so it's each time it comes, it is telling them verifying user candidates, verifying this, verifying that, and they're moving them into the new list. So removing all instance of a specific value from a list. I mean, you can do the dot remove. You can use this. Now you can see we have a list that contains animals, right? And then once you use the while cat in pets, and then use the dot remove, hope you remember the dot remove, right? It removes elements permanently. And then you know, if in the end you print pets, you're going to have an empty list because each time you come back, um, okay, so it's removing only the instance of cats here, not every animal, right? So you can see this is also another example, just removing the instance of one particular element in a list. Because the dot remove, if I have we have come to already agree that if I have norms equal to 112, okay, if I have this, uh, let me call them my list. So if I have my list equal to this, let me print my list. By the way, this that I'm using now is what we call camel casing, where you can start with a small letter and then you join different words. Starting the first word of the first letter of the next word with a caps lock, right? So this is what we call camel casing. Imagine this is the head, or sometimes camel casing could be like this, capital M and then this still works. So imagine this to be like the head, and then this should be like would be like the hunchback of the camel. It's what we call the camel casing, I guess. Okay, now we want to remove all these instances of one from this list. If we just use my list dot remove, and we use okay, let me use four. Let me use four so that we understand which one goes out. Let's you do four. Now let's print my list. Let's see which one went out. Consider the one that went out is the first one. So it checks the first occurrence of the word from sorry of what you want to take out from the right. It checks the first occurrence, right? So the first occurrence was four, and that was from the right. So is this right? Not from the left to the right. Right. So it checks from left to right. We know that pop does from right to left, except if otherwise instructed, right? So you have to understand the direction in which these guys move. So now when you do this, it only removes one instance. What if I want to remove everything there, right? So let me reinitialize my this. Then you can come here and just you can see I did not run this guy, so I'm just gonna take it out. So I'm just gonna while my list. So what do you mean why my list is not empty, right? Then you can just keep on my list. Okay, no, I don't think while my list is not empty is the right. thing we're supposed to do. If not, we'll get stuck. So let's hit we're going to say while four in my list. That is what we want to remove. While four is in my list, right? What do we want to do? Want to use my list dot remove that four, right? Um, so the second four ceases to be part of this guy. The loop breaks, right? So let's do this. Now you can see that the loop stopped, right? And then what do I have now as my list? 1132. And so you can see that every instance of four was taken out, right? So let me just run through this again so that you see. Here we have two instances of four. Here we run this loop, and here all the instances of four are gone. Beautiful. So that's an example. So most of what we were just seeing today are just examples, not really and case scenarios. If you call them use cases, you're not far away from the truth, right? Now finding a dictionary, filling a dictionary rather with user input. Okay, so now supposing we want to create a dictionary, remember our data set from last week. Let's say we want to collect information from people to be able to populate our dictionary and be able to create pandas. Let me see if this is the last one, then we're going to do that. If that's not the last one, then sorry, we're not going to. Oh, okay, you win. So we're going to create our data set. And I want you to really do this. Try to collect data of about 10 people. So what information are we going to collect? I think we're going to collect our our information. I think what information did we collect last week? I think we collected name, collected age. So today we're going to add. Now for you last week, I knew you had something like 5 columns. You can try just maintaining the 5 columns and collect various information. Right. Yeah, so but before then, let's look at this example they did. Right, so this is them trying to vote for. Imagine you're trying to vote for a class rep, right? You're trying to receive responses of people, right? It depends on the name of the person who responded, right? So now we collect your name here, we collect your response, and then we enter them into the dictionary. This person's name, we map them. Your name will be the key. The person you voted for would be the response, right? So let's say the next time you are trying to vote somewhere, you can actually use this. Okay, let's try. This is fun. These are not exhaustive examples. There are so many use cases out there. You can try them out. So here we can have numbers. Okay, rather we can have an empty list. Rather an empty. So here we can have an empty dictionary. We can initialize and then we can call it votes. Call it an empty dictionary. That's our intuition. We start from an empty dictionary. Then we give you while, right? So while true, why we're still doing while true is because we want it to run, and then we would use a break statement to decide when it is time to stop, right? Because in voting situations, you might not actually know the number of people who are going to vote, except if maybe when you started, it is a closed door kind of voting, right? But it's often wise for you to use the while true, not the for loop. Now you do this. So while votes, so while true, we can just collect the name of the voter. But if we collect the name now, it means when two people have the same name in the class, they cannot be able to vote. Like so, we can collect the matric number of the person because not two people will have two matric numbers at the same time. It's not possible. So matric number will use the input to collect. I'll just enter it as mat no, then give a space. Then I'll also collect the vote of the person, right? Vote. Who did you vote for? So we're going to collect that. Then we're going to have matric number. Sorry, rather um, voted for. Let's do this. Just think of any of these things. You can actually paraphrase this depending on where you want, how you want to see your code, right? So what I'm just going to do here is I'm going to populate these votes now. Just come here, populate votes, and tell us, okay, hey, this is what I want you to do now. Remember how we used to populate our dictionary? We pass in what we want to populate. What is the key? We pass in the key here. So this is going to be matric number, right? And then we pass in the value as the vote the person casted, right? Just take a pause, watch this again, and then you would understand. But now we need something that will help us to be able to terminate since we're using while true, right? So you can be able to ask a question, right? Ask, well, let's say response of the person should be, do you want to collect more votes this time around? So I want to ask it if you want to ask if he wants to collect more votes, right? Then we can come here. Okay, we didn't need that. So we can come here and check if response, you know, is equal to yes. So if response is not equal to yes, so depending on what the user types, let's add the dot lower here to be able to handle whatever, whatever the user enters, to be able to lower it. Let's also add dot strip here, right? So what we're doing here is we're saying if the user enters, even if it's capital letter yes, it should convert it to small letters, right? And it should also be able to strip extra spaces if the user mistakenly adds extra spaces either before or after. Our system should still be smart to understand that it should stop, right? Beautiful. So if this, then we can initiate our break. Otherwise, they're asking the user is actually whether he wants to collect more votes, right? So if it's a yes, we want it to go in, right? But if it's not a yes, we want it to quit, right? So that's what we're trying to do here. If the response is not a yes, no or any other thing, the response should cut, right? Okay. Now, let's see this. Now, matric number. Let's just collect for one person and then we stop. So matric number 1042. Voted for. Who are you voting for? Myself. Oh, myself and I. Right, and then we have what do we have next? It asks me, okay, okay. So let's add some like a confirmation message here. Once we are done, let's add something like print. Okay, let's do that here. Print something like vote recorded successfully. Right, vote recorded. Did I get the spelling of successfully correctly? Please, if I didn't correct it in your own successfully. Okay. Let's So we're going to collect this ourselves, and of course, we have to finish this round. Do you want to collect more votes? Um, no. Let me see if this quits. Yay, quit. Now, if since no quits, it means I can use almost anything to, you know. No, it's not supposed to be here. I think it's supposed to be immediately after this place. Beautiful. But while we're having an indent here. Beautiful. Okay, so this is us just trying to find out if we should continue or not. My white space is here just for readability sake, right? So let's do this. Let's collect details for more people. Let's collect let's collect so my matric number is 1042. Who am I voting for? Me, vote recorded successfully. Do you want to vote again? Of course. So I'll add another vote. So what we can do here is we can come back here and add this slash n, right? So that it gives a space. You understand my thought process now. So the next person on 1043, but who are you voting for? Voting for Mama, and then voted successfully. And then, just continue. Who are you voting? Do you want to collect another one? Yes. 1044. Who even had this matric number? Who are you voting for? Let me still vote for myself. I mean, it's life. Voting for money. Yeah. Do you want to collect more? No. Because I want to win the election, right? So it's only people that will vote for me that I'm going to be taking in. That's good. So we're not going to be running this again to see how this is implemented, but you now know, how and why. And so quickly, let's look at what our votes looks like. Now you can see our votes has recorded the votes, right? So we can come here. You can use the for loop if you want for votes in votes for voting votes dot keys. By the way, whether you type keys, if you just use for voting votes, let's say this, then we print vote. we know that it will print only the keys, right? The matrix numbers, right? But if you want um the items or the values rather, you have to pass it in. You must pass it in. Or if you want a tuple containing, both key and value pairs, you must use the dot items. So you can see here we have these are the election results. So finally, we're going to round up by creating, like we said, we're going to round up by creating a function like this that automatically collects three variables, and then in the end we'll have a data set with it. So let's go on with it. Right. So we're going to collect users. Remember, so first let's start from an empty list. Okay, so while true, I'm going to be collecting some variables quickly. So we're going to be having name. Okay, so remember the other time we stored names, right? We'll have sometimes we have a list of names, then we have a list of people. So we're going to collect these guys into three individual lists. Now we need to initialize three empty lists. So next we populate this list with the values we are getting from here, right? So each time we collect these guys, we are actually adding them to this list, right? So once we're done with the collection, we can just come here and say our users now is equal to, we can just collect, we can just create a dictionary. So we didn't even need to create this in the beginning. So we just have a dictionary here where we have name mapped to names list, right? So this will be like the name of the column. This is a list now, right? Let's once you're done collecting, you can check names, right? It will be a list now. Then we collect. Let's follow it with the gender. Then we have the genders, right? And then let's populate it now with the age. The age is correct. So all things being equal, if this works, we should have a dictionary in the end returned after this loop. Okay, so I'll just go ahead and take this out. We didn't need it. Run. Okay, now you can see string object has no attribute at 10. 10. Okay, this is ages here. And you can see that we didn't even ask if we should break or not. That's terrible. Thank God for the error. Would have been having an infinite loop. So we could just come here and ask the person, does this? Now I'll just go ahead and copy this. do you want to collect more information? So generally if it's yes, just brief. So that still works for me. So let me go ahead and run this. Oh, if you want to collect more information, you can see how I made a mistake. I uh I made a mistake here. Now you can see what our list is containing. We have name, two people, gender, two people, age, two people. Just go ahead and bring in our pandas now and see what it looks like. And tada, version 2 of your dataset, right? Last week we saw how you were the one that manually entered your dataset. And now okay, you added a tool today, more knowledge, more technical know-how. You were now able to create a workflow that can enable other people to be able to enter data while you sleep, right? They just keep entering data, and then you now understand the concepts of Google Forms and Microsoft Forms, right? That's you creating one, right? So that is your assignment for this week. So this week, we're now about doing the exercises in the in the book, that is in chapter 7. What we're all about is you doing this. So do this for yourself. That will be your exercise for the week. You create this. You should be able to have up to 5 columns and not less than 10 rows. Right, from 10 rows upward, you can do up to 50 rows if you want, but you should have up to 5 columns, and you should have up to 5 columns and about 50 and about 10 rows. And we also want to see an evidence that you entered this data by yourself, right? So we want to see that. If that's the only thing you get to submit, fine. But if you're able to do the other exercises, it's still fine, right? But this is a must submit for this week. That is to make us see how close we're drawing to the aim of the training in the first place. If you haven't already, it's time to subscribe. And if you have, then it's time to like the video, right? Leave a comment behind for us and keep enjoying. Keep coming back, keep learning. Thank you.